Welcome everyone to the Thomson Reuters webinar introducing our machine-readable news feeds over Elektron to the developer community. My name is Eric Fishkin. I handle product management for machine-readable news at Thomson Reuters. I'm joined today by Zoya Farberov, platform application developer. Today we'll discuss machine-readable news content available over our Elektron platform, which you can access with the standard EMA and ETA APIs. Here is our agenda for today's webinar. I'll discuss the machine-readable news data available over Elektron, use cases, and some examples. As an FYI, there are some other MRN content sets that are not available over Elektron, and those are out of scope for this webinar. Afterwards, Zoya will describe how to subscribe to the data, show demos on working with it, and reveal some technical resources that we make available. At the end, there will be a Q&A session. Let's get started. We're going to talk today about three content sets. We'll start with our real-time news feed, which is based primarily on the news provided to us by Reuters News. Reuters is well known as a premier global news agency. In the financial news arena, it's won awards from Inside Market Data for Best News Provider in 2015 and 2016. In addition to Reuters News, we also make available dozens of other third parties, including leading global press release wires and exchange wires. In addition to the timestamps, our metadata includes over 1,300 topic codes describing events in the data, geographies, regions, markets, business sectors, and other kinds of subjects. There are basically four use cases. The first one is proprietary trading and market making. This is trading or having spreads around unscheduled news events. Then there are execution services. Since it's known that unscheduled news affects trading volume, this allows execution desks to adjust their participation rates. On other trading desks, it can be used for event detection and alerting to send alerts to the trading desk, to the traders, and it's also used for market and trade surveillance to give the compliance analyst a baseline for how to detect insider trading before a news release. Let's now look at an example of how a news release affects equity prices. We're going to show a chart of InvenSense trading on the New York Stock Exchange on December 9th, 2016. We see that these are minute bars, and the top we have price data, and the bottom there's the volume data. We see at the minute ended 11:47, that is between 11:46 and 11:47, the trading volume was 200 shares, and the price ended at 8.33. However, between 11:47 and 11:48, we see that the price spiked by almost $1 on almost 180,000 shares traded. After a 5-minute trading halt, the price spiked almost another $1 on almost another 150,000 shares traded. And then the next minute, it rose further to 10:46 on another 27,000 shares traded. And here is the information release that triggered the spike in price and volume. We see here, this is the headline, the ID, and the provider. This was provided by Reuters News. We see the ID, the unique identifier for the news item, and the headline. The headline says that TDK was in talks to acquire InvenSense, and this is a Reuters exclusive as per the beginning of the headline. It was released at 16:47:20 GMT, or UTC, which is 11:47:20 Eastern Time, which is exactly when we would have expected such a release to have occurred. We see here that also, in addition to the headline, the story was tagged with the RICs. These are Thomson Reuters quote identifiers of TDK and InvenSense, and the perm IDs, which are Thomson Reuters proprietary company identifiers for TDK and InvenSense. For more information on the perm ID, you can see the Open Perm ID API in the developer community, or go to permid.org. In addition to these, we see there are some topic codes. For example, MRG, denoting this is a merger acquisition event. And this tag denotes it as a Reuters exclusive. Now, this kind of release is highly relevant to all the use cases. The proprietary trader would take a long position here on InvenSense, as we saw, and the market maker would take this and widen the spreads or get out of the market to an extent. Execution services will adjust their volume-based trade participation strategies as they expect tremendous trading volume in the coming minutes. For trading desks, we can send alerts to them, alerting them to this event. And compliance will look at this and know when information was released and therefore look for suspicious trading activity that happened shortly before this timestamp. Now we'll discuss our second content set. News analytics is an automated text scoring system that adds NLP data on a number of dimensions. Now, whereas the core real-time news data is the values in the raw text itself, the value here really is in the derived data. The most important derived data here is the sentiment. Sentiment measures author tone toward either an entity in the text or towards the entire document. Relevance denotes how relevant an item is to the news item. So, for example, if an item is in the headline, then it would have high relevance. But if the entity is not mentioned until later on in the news item, it would have low relevance. And it's likely that this news item does not have market-moving information about this entity, and therefore we can filter it. Similarly, novelty is used as a filter. It counts similar news items in a trailing window that are similar to this one. And again, if we find many similar items, we might want to filter this one out. Volume is a simple count of news items on this company or entity or commodity in a trailing period. And headline analysis adds flags for market commentary, analyst ratings or price target changes, and market imbalance. The news analytics data itself includes all the significant news metadata except for the story body. It scores English and Japanese language natively. And in case you're wondering, the sentiment accuracy of our Japanese module far exceeds that of machine translating the Japanese into English and then scoring it in English. We cover companies and commodity energy topics. And we have an additional module that scores entire documents, which is especially useful for macroeconomic news sentiment. The prime use cases here are quant trading and investment, market and trade surveillance, to add filters to the news that we saw, the real-time news, and for research. Now let's look at some sample news analytics data that we've put into Microsoft Excel. On the left, we see the ID of the news item, and then to the right, we see the timestamp in UTC. After that, the third and fourth columns are the RIC and the perm ID. Then we see the attribution. For most of these is Reuters, and the top one is for MarketWired. Then we see that these are articles and alerts, and then we have the headline. Over on the very right, we see the positive, neutral, and negative sentiment scores. You'll see that these are all between 0 and 1, and they sum to 100%, because these are viewed as probabilities that the author was positive, neutral, or negative toward the particular entity we're scoring. To show you an example, in the first item, tech to acquire 100% of the Teen Rewards Zinc project, the sentiment is overwhelmingly positive toward tech. However, in the second to last one, Shell announces nearly 400 job cuts in Scotland. The sentiment is strongly negative. In most cases, the relevance, which is just the left of the headline, is 100%, where the company is mentioned in the headline. However, in other cases where it's mentioned later on, it has lower relevance. For example, in this case, where Rick misses a coupon payment, the company RIC is SGXX.SI, that's the Singapore Stock Exchange, and we see that this is not mentioned till the 8th sentence of the story, which is a 13-sentence story. So in other words, it's not mentioned until the second half of the story, and therefore the relevance is low. Another example, now we'll show novelty. We see here two headlines that are very similar. One was released about an hour and a half after the second one, and we see, as expected, that the novelty count increases. The second item detected that there were 3 previous stories that were similar to this one, whereas the one before it said only 2. So this makes sense. In other words, the second one is adding the one we see before it to the novelty count. We see here, well, let's look now at exchange action, at broker action, and price target. So here we see that HSBC raised the price target of UniCredit and maintains the rating at a buy. They had earlier raised the rating of UniCredit to a buy several months before. And as you'd expect, we see that in the two fields here, broker action and price target, that the rating is scored as a maintain, and the price target is an increase. Now let's look at this headline. French and Benelux stocks, factors to watch. This is more of a market report, and tends not to have market-moving information on individual companies. And as a result, many users would want to filter this out. To help them do this, we provide a market commentary tag. And as you see, we've marked this as true. Let's now move on to the final MRN content set that's available over Elektron. News sentiment indices provides trailing window sentiment and volume aggregations based on news analytics. It takes the 3 sentiment scores and creates one single score that we call net sentiment, and this is simply the positive minus the negative. We aggregate the net sentiment, the news volume, over 4 look-back periods: 1 hour, 4 hours, 24 hours, and 7 days. It scores companies and company roll-ups based on Thomson Reuters official indices, for example, the Thomson Reuters U.S. Energy Index. The primary use for this is probably in charting. So for example here, we've taken a price chart of Apple, and we've taken the 1 day, the 24-hour news sentiment index on Apple, and aggregated further over a 20-day period. And we see here an interesting pattern. We do see around November 29th that the sentiment on Apple starts to peak up before the price does. Now let's look at some sample data. We see here the we see the ID again. This matches to the ID of the news item, and we see a timestamp. We also see that this particular score is going to be on Natus Medical. So we have here the 4 windows: 1 hour, 4 hours, 1 day, and 7 days. And the item counts for these are all 1, which means that this is the first news item that we scored on Natus Medical in the previous 7 days. And therefore, the sentiment averages for these are all the same as well. Now let's look at some of the roll-ups. This individual item triggered roll-ups on the TRUS index. And as you see, the item counts here are much larger, as you'd expect. And also the TRUS Healthcare Index and the TR Global Index. And with that, I've concluded our discussion on the MRN content and the examples. Thank you for your time. I'll now turn it over to Zoya Farbarov. Zoya?
Hello, everybody. Thank you, Eric. As Thomson Reuters developers, we like to understand the content set in terms of rigs used to subscribe to the data. These are the rigs that we use to subscribe to MRN data. MRN story is real-time headline and story newsfeed. MRN TRNA is news analytics on assets, companies, and commodities. MRN TRNA doc is news analytics on other potentially market-moving news articles. And MRN TRSI is an index of news analytics where sentiment scores are aggregated per time intervals. MRN data is published over Elektron using Open Message Model envelope in News Text Analytics domain. All MRN messages are in the same envelopes, and different content is stored within fragments of type buffer. When the data is published, it's formatted as JSON strings, compressed, fragmented if the item is too big to fit within one update, and enveloped to be published. 5 fits, as well as the rig itself, are important to determine how each item is being received and how the total original item can be reassembled from the received updates. MRN source is identifier of the scoring processing system that published the fragment. GUID is a globally unique identifier for the data item. Fragment is the actual data that's being published. That's compressed data that we are going to decompress and reassemble. Tot size is the total size of the complete data item. So if the item is being fragmented across several updates, then tot size will be how many bytes we expect to receive in total. And fragnum is a sequence number of a particular fragment. We identify an MRN data item by the combination of the following: rig, original rig that it was subscribed on, and the 2 fits MRN source and GUID. It can either consist of a single fragment, in which case the tot size will equal the number of bytes in the fragment and the frag num will be 1, or this combination can apply to the multiple fragments if the story is big, and then total size will equal the number of bytes in all the fragments, and the fragments will be numbered with frag num starting from 1 and going 1, 2, 3, and so on. And this is what we do as a subscriber application. We prepare our callback and we process the incoming fragments. We accumulate them. Once we have the number of fragments reach the total size, then we're ready to proceed and to decompress, unzip them. Let's discuss the approach to subscribing and parsing MRN data. As the envelope is the same for the 4 MRN data feeds, the approach to subscribing and parsing will also be the same. We connect using configuration to the required infrastructure. We define our callbacks, and we register interest in the required Elektron service by specifying one or more MRN rigs. Domain is news, text, analytics domain. Once we receive the updates in our update callback, we will store fragments for reassembly. We look for feeds of type buffer and feed of fragment. We uniquely identify the item by the combination of rig, MRN source, and good. We also look for feed tot size, and we concatenate the fragments that we receive until the concatenated data reaches tot size in size. Once it's reached, we're ready to unzip it using gzip and to create JSON object out of the unzipped string. Let's take a look at some of the feeds that we should be encountering in the envelopes. There are 3 types of MRN envelopes that we could be seeing. The initial refresh set consists of 16 feeds. First fragment will be 10 feeds, and subsequent fragments, if there is more than one fragment in a specific item, would just be 4 feeds. And I will also point these messages out when we are running the demos. These are specific items that are found within JSON as part of story. Real-time news contains headline, story body text, and associated metadata. So this is example feeds that could be found in the story. Alt ID is actually the story identifier pinnock that could be used to directly reference and subscribe to this data. First created, headline of the story that was published, ID, and provider who provided the specific item of news. News analytics will be hierarchical, and it has 3 top-level items. Subgroup containing analytic scores, ID that ties this item to the original news item, and subgroup containing information about the news item that was used to generate the analytic scores. These will apply both to asset level and document level news analytics. And on the right, you can see example feeds: sentiment negative, sentiment positive. Another very important item that we often look for is relevance. How relevant the score is to a specific asset. TRSI feed has a group of named values including an array of scores, SI scores. Each SI score group contains all the rolled up analytics information for a specific asset as a simple group of named values, sentiment averages. And sentiment average group is used to associate a count and an average with the window of time it relates to. And the example on the right hopefully makes it easier to understand what is meant by that. So sentiment was averaged 0.1234 over a window of 1 day. We're going to take a look at 4 demos today. MRN Streaming Console, which is a simple example illustrating subscription and putting out data on the console. GUI Viewer for comparison. Store, database store, as well as a correlation example that correlates MRN data with DSS data. First, we look at the streaming console. That is a simple, straightforward example that exemplifies the approach to retrieving MRN data. First, we establish connection with the infrastructure where Elektron feed is hosted by specifying host and port. We register client interest callbacks on Elektron service for domain model news text analytics. And in update callback is where we do the main processing. As the updates arrive, we accumulate the updates. We wait for the total size of the fragments to reach the expected total size of the message. Once that happens, we concatenate the fragments, unzip the message using gzip, and recreate the original JSON object. In this specific example, we also pre-print JSON object to console, which results in updates streamed to the console just as they arrive. We are looking at News Analytics Streaming Console example that's developed using EMA Java 107, Oracle Java 1.8 in Eclipse IDE. This very simple example includes EMA library, as well as ETA libraries that underneath EMA, and Java JSON jar for parsing JSON. The project consists of a single Java file, MRN consumer class. Let us examine it closely. As command line arguments, this example accepts the configuration parameters to connect to the infrastructure we are going to subscribe MRN data from. So we see host, port, as well as username to connect with, and they are being used when we create the app client and config. What we're doing is we're establishing connection to the infrastructure using these parameters here. It's a bit of a mover. There you go. So IP, port, and username. Next, we're going to register interest in domain MMT news text analytics for service name Elektron and to a specific rig, which will be one of the MRN rigs, MRN story, MRN TRNA, one of these. And now let's examine the callbacks, the client callbacks where we are processing this data. So on refresh message, we're going to decode. On update, we're also going into decode. And on status, we just printed to the screen. Let's see what we do in decode. We are looking at the fields within the updates, and specifically we're searching for field of type buffer by the feed fragment. This is where our actual data is being packaged. Other field of interest are dot size. We are noting the total size of the message that we are about to process, and GUID, which is how our data is being identified. You probably recall that to get a complete unique identification of an MRN item, we need 3 things: rig, MRN source, and GUID. In my case, however, I'm only subscribing a single rig, MRN story, for this example. And therefore, my rig will always be the same, and so will MRN source. So what I really need to know is the GUID. How am I planning to use the GUID? We are going to create a hash of fragments that we're going to key on GUID. in it gonna go the fragments that already been received. And let us see how we do it. If we receive a fragment and total size of the byte buffer is the same as the total size we expect to receive, then we don't need to store anything, because this item consists of a single fragment. Therefore, what we do is we unzip this data. From the resulting string, we create a JSON object and we pretty print it to the screen. In the case when the message consists of more than one update, more than one fragment, if it's too big basically to fit within a single update, what we do is first we see if our frag builder hash already contains a GUID. If it does not, then we need to create a new array list of byte buffer and add this to it and place it within the frag builder hash for future reassembly. If it already in there, then we get what we already had. We calculate the size of the fragment that we already have, and if it's less, then we add ours in and wait some more. If, however, at this point size equals the expected total size, then what we do is we concatenate the fragments, unzip the resulting concatenation, from the unzipped string recreate JSON object, and pretty print it to the screen. I'm about to run streaming console example so that we can examine the output together. First, we establish the connection and see that the state is open and item name is MRN story, and now let me just stop it and take a better look at the consequent output. After we have received our initial refresh, we are going to receive an update, and this is the update we are looking at. 10 fits envelope, and this happened to be a story. This is the raw output. Then we see the JSON string, and as it's not easy to read, next we pretty print it to see the contents. We first looking at the metadata that's pertaining to this specific story, and then we are looking at the headline and the body, if the story contained the body. Let's examine the next one. Again, we see 10 fit envelope, so it's a new item. It's not next fragment for the previous item. We see JSON string and we pretty print it with metadata. Let's see here, and let's examine one more. You see this one is bigger, so what we find here is the actual body of the story expect. This is the metadata pertaining to the story. There is even more metadata pertaining to the specific one, and then we see the body of the story with the headline and the metadata fits. MRN GUI Viewer is a Java FX GUI example that's built in NetBeans. Uses the same subscription and parsing semantics as streaming console. We enter configuration for a specific connection, and then we lay out the 4 MRN data feeds data side by side. That allows us to be able to examine the data visually, better understand the expected structure of the messages, the content of the messages, compare the 4 feeds, and if we are not sure what data is required for our use case, it allows us to better select the data per requirement. We can pause the streams, copy the relevant data pieces out to the clipboard, and then paste it into an editor and again examine in more detail. And next we're going to demonstrate that. First I'll run the GUI viewer and then we'll go over the source code. We are connecting to the infrastructure. And as I initiate the connection, I see in the status window how my feeds are being connected. So let's see, TRSI open, doc open, story open, and tRNA is open too. So on the screen we see the output for our feeds. If we are interested in a specific piece of data, what we'll do is we pause this specific output and we can copy the contents and take them out into an outside editor for more detailed examination. So in this case, the sentiment average for 1 hour and 4 hours was 0. However, for 1 day and for 7 days, it was slightly bigger. If we see a story that's of interest to us, such as this one here, we can take the text of the story and do the same thing. Copy and paste out into the editor. Once we have examined the story, we resume the output. Next, we examine the project that was developed in NetBeans IDE and take a walk through the code. The project includes the libraries. Here they are. It's EMA Java, ETA Java that's underneath EMA, Java JSON for parsing JSON, and JavaFX extension for JavaFX GUI. Project includes 2 Java files. MRN consumer that's responsible for MRN specific processing for connection, subscription, parsing, and also FX main responsible for laying out Java GUI itself, updates, buttons, layout. So first let's take a look at the MRN consumer. Let me expand it so we are better able to see. It starts with 4 rigs. So this array here, let me show you, contains the 4 rigs that are used for MRN subscription: MRN story, MRN tRNA, MRN tRNA doc, and MRN tRSI. When we have connected and are establishing subscription, we are registering with domain news text analytics, our service, Elektron service, and as we're passing the rig for subscription, we're also passing a closure. This closure is an order in which the rigs are stored in rigs MRN array of string. So if it's MRN story that is stored first, we will pass 0. If it's MRN tRNA, will pass 1, doc will pass 2, and SI will pass 3. When the update comes back, we will look for this closure that we passed. So on refresh message, we decode. On update, we also decode. And on status, we print it to the screen. Interesting part of the decoding is right here. So when we received our fragment, we also received a closure. And in closure, we check which one is it for. And as we update text area of the GUI, we pass it which of the text areas to update. So let's check it out. Going now back to fx main. We updating text area and laying out the received text. We are appending it to the text area. Let me also go a little bit over the fx main. We are just laying out in terms of grid and pane various specific characteristic. What we are doing is that we are dividing equally the real estate among the number of text areas that corresponds to the number of our rigs, and also we are minus the configuration area, and we are laying everything out, and each text area has its corresponding button that is handling the stop button action, freezing the text area, and this is the button that handles connect. Once connect is received, we pull out the configuration parameters and pass them to our consumer to initiate the connection for us, and then it will go in the subscription and it will do the MRN related processing, while this piece here, the GUI, will be responsible for the GUI. MRN data can be conveniently stored into a database. Next example, MRN store, introduces mapping MRN data into custom objects and storing them into a database. We used tRNA rig for the example, and news analytics data are being stored into MySQL database using Eclipse link as object mapper. We examine the data using HiDSQL tool, which again can be examined using any other tool that you find convenient, and our object layout includes two objects. There is tRNA rating that defines the ties between the fragments and the original story, and the analytics score that carries the actual asset IDs that are being scored and the sentiment ratings. Let us examine MRN store example developed in Eclipse using EMA Java version 107, Oracle Java 1.8, and also MySQL connector and Eclipse link. Let us take a quick look at the libraries. These are the libraries used. We are seeing EMA Java. We are seeing ETA Java underneath EMA Java. Also SQL connector, Java persistence, Eclipse link to map our objects, and Java JSON jar to parse JSON. The project consists of 4 Java files. MRN consumer is a top-level file responsible for parsing MRN, processing, and handing over to persister for persisting. And the news analytics objects are laid out in terms of 2. News analytics data is laid out in terms of 2 custom objects, tRNA rating and news analytics score. We will go over this in more detail, but first let me show the Eclipse link persistence config. These are the 2 key objects that are being persisted: tRNA rating and analytics score. And other things you see is just connection and configuration parameters to connect to MySQL. So in MRN consumer, which is our main MRN subscription class, we are taking on the command line parameters various configuration parameters that we require in order to establish connection with our Elektron feed subscribed to MRN, in order to establish connection with our MySQL database, to insert our objects there. And once we have that, we are going to establish connection, and we're going to register client interest and provide the callbacks. Let's see the callbacks. There is on refresh that does decode. There is on update that also does decode. And on status, we're just printing it out to the screen. So what do we do on decode? On decode, we will parse our fragments, bring them to the object state, and persist them. So let us take a look. Once we are ready, we are going to persist our rating here. We are persisting it via persister. Persister is responsible for persisting two kinds of objects: the rating and the analytic score. And we're just using clips link and we're persisting the object. Let's now examine the object itself. So TRNA rating is a custom object that contains the identity of the original item. So there is actual byte fragment being stored together with the GUID that it's relevant to and fragnum and the date when it was stored. And via this object we can recreate the original item, the original story. So the second object, analytic score, contains the analytic scores pertaining to these items, and it includes various IDs of the asset that's being analyzed, as well as the scores, the sentiment scores and the relevance. ID is the ID of the original item that the ratings are for, and it correlates back to the TRNA rating. And now we examine the database that we've created using this example. It contains two tables, TRNA rating that we've defined via Eclipse link, and analytic score. Here is TRNA rating data. For the most part, this data only has one fragment. However, some data has more than one fragment too. For example, this item here, we can see that to this GUI, two fragments correlate. So let us take this GUI and pull the data out for close examination. If we select from TRNA rating on this GUI, we can see the two fragments, and whereas the first fragment had active date, the second one did not, and it had time act millisecond. Second one did not have this information. So this is a single item here that's represented by two fragments. If we select on this fragment from analytic score table, we should be able to see what assets were rated in this specific item. And these are the various identifiers, and these are the sentiment ratings and relevance of this specific item to specific asset. MRN DSS example introduces correlating two sources of data, one of which is MRN News Analytics. This example is part of a large set of examples that correlate one or more sources of data with MRN data. Let's discuss how we're going to go about this. First, we retrieve a region of MRN data limited by interval of time. prior to that, MRN data is already stored in MySQL using News Analytics Store example. Once the data is retrieved, we output it into a CSV file. Next, we retrieve trades data via DSS2 REST service. We request a raw extract based on the same dates. We just go a little bit wider than we did for MRN. We await the response to be received, parse it, and output it into a CSV file. Once we have two CSV files, we correlate data for a specific rig. We open it in Excel, select rig, and chart sentiment to time. Again, we also, for the DSS extract, we chart trade price over time, and then we visually examine and compare the two charts. We are looking at News Analytics DSS example project that was developed in Eclipse IDE. Let us first examine the included libraries. Notice that EMA Java is not included in this project because as prerequisites to this project, the MRN data already has been subscribed and it is stored in MySQL database. So we're just going to use the SQL connector at this point. Top level class is called Analyzer. Let us take a detailed look at the Analyzer. Analyzer, as its configuration parameters, accepts various connection criteria for connecting to MySQL database, for connecting to REST service that's going to allow us to retrieve data scope, select data, and also is a start and end of the time interval. So first, we use our DB interactor to retrieve MRN data from MySQL database. We are selecting from analytics score table, and then we're formatting our data, and we're going to put it into a flat file, CSV formatted flat file. We are going to introduce various formatting so that it's easily accessible and viewable. Other important things that we do will be interacting with Datascope Select to REST web service. Let us go back to Analyzer at this point. So, first we retrieve MRN data, and as we retrieve it, we note the rigs that are included in this specific analytics. Once we have the rigs that have been analyzed, we can choose which of these rigs to correlate with Datascope Select data. And we could, for example, correlate everything that pertains to London Stock Exchange. In my case, what I wanted to do is I wanted to define maximum number to select. I did not want more than 25. And I also did not want any from either Tokyo or Hong Kong. What we're going to do is we're going to create custom raw extract, and we're going to request data from Datascope Select. Let's just take a look. So what we're doing is we're forming a string, we're requesting trade prices as well as volumes and exchange times, but we are going to concentrate on prices that we pull per time. Once request is placed, we're going to await the response. So, going back to our analyzer now, we have issued the request, and if the job was placed, we're going to wait for the response. We do receive our response, which we're going to parse and process, and we're going to also output it into a flat file when it's ready. So let me just show you that what's happening is we are also outputting it into a flat file. So to reiterate the steps that we've taken, what we're doing is pulling from our MySQL database rigs based on time interval. And for the same interval, just slightly wider, we're doing 10 minutes each way. We are selecting trades data from data scope select and retrieving both kind of data. Once we have it, we output into flat files. We are looking at the two data files that were collected by our example, MRN ratings data and trade prices. We are going to look at them and examine them using Excel. So we can see that price was not really moved by the sentiment in this specific case. We'd like to introduce you to the resources that are available to developers who are looking to learn MRN. On the developers portal, you'll be able to find tutorials, downloads, and documentation that could help you in this task. This concludes our presentation on machine readable news. We hope you found this information useful to you. Any questions on this?